Hello students, in this video we will discuss kinetic friction, coefficient of kinetic friction, motion of a block on a rough horizontal surface, and also the motion of an object or a block over a rough inclined plane, downward motion and upward motion, to derive the expressions for acceleration produced. Of chapter 5, NCERTnew book, chapter 4, laws of motion, topics related to friction for class 11 physics and also for NEET and IITJEE entrances. First of all, we have to discuss kinetic friction and its two types, sliding friction and rolling friction. Kinetic friction is the frictional force acting between two surfaces ड्यूरिंग देयर रिलेटिव मोशन. जब दो ब्लॉक के सरफेसेस के बीच में रिलेटिव मोशन होता है तो उन कॉन्टैक्ट सरफेसेस के बीच क्रियाशील एक्ट करने वाला जो अपोजिंग फोर्स होता है, फ्रिक्शनल फोर्स होता है, उसे काइनेटिक फ्रिक्शन कहा जाता है. सो राइट डाउन द डिफिनेशन ऑफ काइनेटिक फ्रिक्शन. द फ्रिक्शनल फोर्स acting between two surfaces in contact during their relative motion. During their relative motion is called kinetic friction. There are two types of kinetic friction. First is sliding friction and second is rolling friction. Rolling friction that is force of rolling friction is smaller than the sliding friction. It is easier to roll a body in comparison to push और पुल. किसी बॉडी को रोल करके एक जगह से दूसरी जगह तक ले जाना ज़्यादा ईजियर है इंस्टेड ऑफ बाय मूविंग ए ब्लॉक और ए बॉडी बाय पुशिंग इट और पुलिंग इट. सो देयर आर टू टाइप्स ऑफ काइनेटिक फ्रिक्शन. नंबर 1 इज स्लाइडिंग फ्रिक्शन and number 2 is rolling friction. First type of kinetic friction is sliding friction, and it is the friction or frictional force acting between the surfaces, contact surfaces of two blocks when one body slides over the surface of another body. The frictional force coming into play in this situation is called sliding friction. Suppose block B moves or slides over the surface of the lower block A. B is in motion. B slides over the surface of block A, that is lower block A. Upper block is B. Block B is sliding. Therefore, therefore between two contact surfaces, that is contact surfaces of blocks A and B, an opposing force is produced, and that opposing force is called a static friction, Fs. That is sliding friction. That is it is also denoted by the symbol Fs. So it is sliding friction. Normal reaction of the surface of lower block A, which acts vertically upward, balances the weight of the block B, which is kept over the lower block A. mass of block B is if mass of block B is m, then weight of this block is W is equal to mg, acting vertically downward, and this will be balanced by the normal reaction which acts by the surface of a lower block A on block B. That is reaction of weight is normal reaction, which acts in vertically upward direction. So weight of the block B is balanced by the reaction force of the surface of the lower block, upper surface of the lower block, that is A. That is N is equal to mg. The block is in vertical equilibrium, but the block B is sliding over the surface of block A. So an opposition, that is opposing force, is produced between two contact surfaces, and it is sliding friction. One example of sliding friction is when a wooden block slides over, when it is pushed or pulled over a surface, then sliding friction coming into play between two surfaces. That is the surface of the block, wooden block, which slides over and another surface, and the surface on which the body slides, that block is, wooden block is pushed or pulled. जब किसी वुडन ब्लॉक को किसी सरफेस पर स्लाइड कराया जाता है या पुश या पुल किया जाता है, तो बोथ सरफेसेस के बीच में जो अपोजिंग फोर्स एक्ट करता है, दैट इज जो फ्रिक्शन कमिंग इनटू प्ले, उसे स्लाइडिंग फ्रिक्शन कहा जाता है. एंड सेकेंड टाइप ऑफ फ्रिक्शन ऑफ स्लाइडिंग फ्रिक्शन इज व्हेन द फ्रिक्शनल फोर्स राइट डाउन फ्रिक्शनल फोर्स एक्टिंग between two surfaces in contact. If a block slides over the another surface, the friction force acting between two surfaces in contact, if a block slides over the another surface, it is called sliding friction. जब कोई ब्लॉक किसी सरफेस पर, किसी दूसरे सरफेस पर, किसी ब्लॉक का सरफेस किसी दूसरे सरफेस पर स्लाइड करता है, या उस सरफेस पर उसे पुश या पुल किया जाता है, तो उस सिचुएशन में जो बोथ कॉन्टैक्ट सरफेसेस के बीच में जो अपोजिंग फोर्स एक्ट करता है, उसको स्लाइडिंग फ्रिक्शन कहा जाता है. तो दिस इज द फर्स्ट टाइप ऑफ काइनेटिक फ्रिक्शन, बिकॉज in case of sliding, during sliding, the body is in motion. Second type of kinetic friction is rolling friction. When a body rolls, say a wheel rolls on a road, then the friction or frictional force, opposing force acting on the wheel, which opposes the motion of the wheel, suppose, it is called rolling friction. So second type of kinetic friction is rolling friction. Rolling friction, when a block or a body, say a wheel, rolls over a surface, the position, that is the block, rolling block, encounters opposing force or frictional force, which is called by the surface on which the body is rolling, is called rolling friction. So a body, say a wheel rolls over a surface, then the opposition, that is resistive force suffered by the rolling block rolling body by the surface is called rolling friction. Rolling friction is smaller than the sliding friction. It is easier to roll a body instead of pushing or pulling it. किसी बॉडी को रोल कराकर मूव करना ज़्यादा आसान है, ज़्यादा इजियर है, मोर इजियर है instead of pulling or pushing that body. So rolling friction is smaller than the sliding friction. That is, we can write Fr, rolling friction. Fr is smaller than the sliding friction, Fs. We can write it. That is, rolling friction, Fr, denoted by the symbol of small f, suffix in suffix r, Fr, a small f in suffix a small r, a small x and suffix में a small r है, and it is smaller than a smaller का sign inequality than the sliding friction Fs. Now cause of rolling friction. What is the cause of rolling friction? When a body, say wheel, rolls over a surface, then it depresses, that is, the body depresses the surface under it. Therefore, a bump is formed ahead of the depressed part of the surface. And in climbing the bump, the body, say wheel, encounters or faces some opposition or resistive force in motion of the wheel, and it is that is rolling friction coming into play. This is the cause of rolling friction. So write down, when a body, say wheel, अगर कोई बॉडी सपोज किया जाए, कोई व्हील है, पहिया है, मोटर व्हीकल्स का व्हील्स रोड पर जब मोशन करता है तो रोल करके मोशन करता है. तो जब कोई बॉडी किसी सरफेस पर रोल करता है तो उस सरफेस का, उस व्हील के नीचे का जो सरफेस है वो थोड़ा डिप्रेस हो जाता है, थोड़ा दब जाता है. एज ए रिजल्ट, in front of the depressed part, bump is produced. जो depressed part है व्हील के नीचे, उसके आगे का पार्ट थोड़ा सा वहां बम्प हो जाता है, माने थोड़ा सा उभार हो जाता है. और उस उभार पर क्लाइंब करने में, उस उभार पर चढ़ने में व्हील को थोड़ा रेजिस्टेंस, मतलब व्हील को अपने मोशन में थोड़ा रेजिस्टेंस प्रोड्यूस होता है. अपोजिंग फोर्स प्रोड्यूस होता है, फ्रिक्शनल फोर्स प्रोड्यूस होता है. दैट इज कॉल्ड रोलिंग फ्रिक्शन. दैट इज रोलिंग फ्रिक्शन इज प्रोड्यूस्ड इन दिस वे. तो व्हेन ए बॉडी विल rolls over any surface, the surface under it, that is under the wheel, the surface under the wheel के नीचे का जो सरफेस है थोड़ा डिप्रेस्ड हो जाता है, दब जाता है. व्हील अंडर द व्हील इज डिप्रेस्ड एंड इन फ्रंट ऑफ इट, जो डिप्रेस्ड पार्ट है व्हील के नीचे का, उसके आगे बम्प प्रोड्यूस हो जाता है, उभार प्रोड्यूस हो जाता है. एंड इन फ्रंट ऑफ इट, दैट इज द डिप्रेस्ड पार्ट ऑफ द सरफेस. सरफेस का जो डिप्रेस्ड पार्ट है उसके आगे बम्प, उभार प्रोड्यूस हो जाता है. डिप्रेस्ड पार्ट है तो वहाँ गड्ढा हो जाएगा. व्हील के नीचे का जो पार्ट है, व्हील के नीचे जो सरफेस है थोड़ा सा डिप्रेस्ड हो गया तो वहाँ गड्ढा बन गया, और उसके आगे क्या है, उभार प्रोड्यूस हो जाता है, बम्प प्रोड्यूस हो जाता है. अब व्हील को डिप्रेस्ड पार्ट से, गड्ढा से उस उभार पर, बम पर क्लाइंब करने में, चढ़ने में व्हील रेजिस्टिव फोर्स, रुकावट महसूस करता है। दैट इज द व्हील इनकाउंटर्स opposition of motion of the wheel, and that opposition is produced in form of rolling friction. तो व्हील का डिप्रेस्ड पार्ट से बम पर जो भार है उस पर चढ़ने में थोड़ी रुकावट होती है, उसकी गति में, व्हील की गति में रुकावट उत्पन्न होती है, अपोजिशन प्रोड्यूस होता है और वही रोलिंग फ्रिक्शन के रूप में प्रोड्यूस होता है। तो दिस इज द रीजन ऑफ रोलिंग फ्रिक्शन। सो cause of rolling friction is when a body, suppose say a wheel rolls over any surface, the surface under the wheel is depressed, and in front of it, in front of the depressed part of the surface, in front of it, bump is produced. We can also demonstrate in a diagram. That is, during the motion of a wheel, over a surface, the surface under it is depressed. The surface below the wheel is depressed. The surface below the wheel is depressed, and in front of the surface, that is in front of the depressed part of the surface, the surface is elevated now. That is it is bump in front of this depressed part. This is the depressed surface, that is depressed surface below the rolling wheel. When the wheel is rolling, the surface below the rolling body is depressed. अब जब डिप्रेस्ड हो गया तो उसके आगे का जो सरफेस है, उसके आगे क्या हो गया, थोड़ा उभार हो गया, बम्प, एलिवेटेड हो गया वह पार्ट, माने इस डिप्रेस्ड पोर्शन के रेस्पेक्ट में। अब इस उभार पर जब व्हील चूंकि आगे बढ़ना है, तो व्हील जब आगे फर्दर रोटेट करना चाहेगा तो इस डिप्रेस्ड पोर्शन से बम, जो ये एलिवेटेड पार्ट है उस पर क्लाइंब करने में, तो अपने रोलिंग व्हील अपने मोशन में रेजिस्टेंस, ऑब्स्ट्रक्शन फेस करता है, इनकाउंटर करता है, जो कि रोलिंग फ्रिक्शन के रूप में प्रोड्यूस होता है। तो इस सरफेस के द्वारा इसके बॉडी के, माने इस रोलिंग बॉडी को डिप्रेस्ड पार्ट ऑफ द सरफेस से बम पर क्लाइंब करने में सरफेस के द्वारा अपोजिशन ऑफर होता है, जो कि क्या है, रोलिंग फ्रिक्शन। इन क्लाइंबिंग अप द बम्प, the wheel, that is the rolling body, the wheel encounters or faces opposition in its motion. Wheel अपने मोशन में रुकावट महसूस करता है by the surface. Opposition. In climbing up the bump, the wheel encounters or faces opposition in its motion, and this opposition is produced in form of rolling friction, which is rolling friction. That is, rolling friction is produced. जो अपोजिशन है मोशन में, जो सरफेस के द्वारा जो अपोजिशन ऑफर होता है डिप्रेस्ड सरफेस से बम्प पार्ट पर क्लाइंब करने में, जो ऊंचा एलिवेटेड पार्ट है आगे डिप्रेस्ड पार्ट के, तो उस पर चढ़ने में व्हील रुकावट उत्पन्न करता है, अपोजिशन प्रोड्यूस करता है सरफेस के द्वारा, जिसे जो कि वह अपोजिशन ही क्या है, रोलिंग फ्रिक्शन, दैट इज रोलिंग फ्रिक्शन इज प्रोड्यूस्ड। which is rolling friction, that opposition is called rolling friction, that is rolling friction is produced. This is the cause of rolling friction. Rolling friction is produced. Now we will discuss motion of a block over a rough horizontal surface. We have to obtain the expression for retardation of a block moving over a rough inclined surface, and also we will obtain the formula for a stopping distance. If the block is finally comes to rest, what will be the stopping distance? What will be the distance covered by the block before coming to rest on a rough horizontal surface? That is very important problems-based formula they will derive, and also formula for work done by the frictional force in that case. So next topic is motion of a block over a rough horizontal surface. When a block moves over a rough horizontal surface, then the block encounters opposition of motion in form of kinetic friction or sliding friction. And to maintain the motion of a body of that block, the force acting on the block to maintain its motion is mass into acceleration, ma, and it is counterbalanced by the frictional force. बॉडी को रफ हॉरिजॉन्टल सरफेस पर मेंटेन करने के लिए जो फोर्स चाहिए, दैट इज मास इनटू एक्सेलरेशन में कैपिटल M इनटू A, तो वह फ्रिक्शनल फोर्स को, स्लाइडिंग फ्रिक्शनल फोर्स को ओवरकम करता है, काउंटर बैलेंस करता है. Therefore we can write M into A is equal to mu k into N. Mu k into N is the force of kinetic friction acting between, or force of sliding friction acting between two contact surfaces. So we have to discuss motion of a block on a rough horizontal surface. Rough horizontal surface. Suppose a block of mass m is moved over a rough horizontal surface with a speed u. The body is projected with a speed u over a rough horizontal surface. This is the block B. This is the rough horizontal surface. It is rough horizontal surface. Say it is figure 1 in this case of this topic. Weight of the block, suppose mass of the block is a small m. Therefore weight of the block x vertically downward. अगर ब्लॉक B का जो कि मोशन कर रहा है रफ ओरिएंटल सरफेस पर, सपोज किया जाए वेलोसिटी इसका u है, रुक का वेलोसिटी, इनिशियल वेलोसिटी, तो इस वेलोसिटी से u वेलोसिटी से बॉडी मूव कर रहा है राइट डायरेक्शन में रफ ओरिएंटल सरफेस पर, तो ब्लॉक का वेट, ब्लॉक बी का जो ब्लॉक स्लाइड कर रहा है, तो उसका मास सपोज किया जाए m है, तो उसका वेट, ब्लॉक बी का वेट सरफेस से, रफ ओरिएंटल सरफेस से होकर डाउनवर्ड एक्ट करेगा mg, एंड सरफेस का, रफ ओरिएंटल सरफेस का रिएक्शन भी, नॉर्मल रिएक्शन भी इस पर, इस ब्लॉक पर अपवर्ड डायरेक्शन में एक्ट करेगा, एंड दैट नॉर्मल रिएक्शन इज m. एंड in the vertical equilibrium, it is the case of vertical equilibrium, that is in the vertical direction both forces, that is normal reaction, balances the weight of the block. So there is no motion of the block along the vertical direction. Only motion of the block will be along the horizontal direction. And frictional force acting, frictional force, that is opposition force, that is force of sliding friction or kinetic friction. Sliding friction is one of the types of kinetic friction. So kinetic friction will act into play between two contact surfaces, between the surface of block B and the rough horizontal surface, and it is mu k into, mu k is the coefficient of kinetic friction, mu k into n. Coefficient of kinetic friction mu k is the ratio of kinetic friction and normal reaction. Mu k is equal to coefficient of kinetic friction is a constant of proportionality. It is equal to force of kinetic friction Fk upon normal reaction n, and force of kinetic friction is mu k into n. Force of kinetic friction is mu k into force of kinetic friction Fk is equal to mu k into n, and from this we have obtained coefficient of kinetic friction mu k is equal to the ratio of kinetic friction Fk, force of kinetic friction between two surfaces, and normal reaction. And n is balanced by mg. In place of n we can write mg. And coefficient of kinetic friction is a constant of proportionality, because from one of the laws of kinetic friction, force of kinetic friction is directly proportional to normal reaction n. Therefore, Fk can be written as Fk is equal to mu k into n, where mu k is a constant of proportionality, which is called coefficient of kinetic friction, similar to the coefficient of static friction. The value of kinetic friction mu k is smaller than the coefficient of static friction mu s. Mu k, coefficient of kinetic friction, similar to coefficient of static friction, depends on the nature of the contact surfaces. So the force of kinetic friction acting between the moving block, that is sliding block B, over the rough horizontal surface, Fk is equal to mu k into n, and n is equal to mg. Normal reaction of the surface balances the weight of the body. नॉर्मल रिएक्शन अपवर्ड डायरेक्शन में, वर्टिकल अपवर्ड डायरेक्शन में, बॉडी का ब्लॉक बी का वेट डाउनवर्ड डायरेक्शन. मेन balances the normal reaction, balances the weight of the body. So coefficient of kinetic friction between two surfaces, that is surface between the surface of the block, contact surface of the block, and the rough horizontal surface of the rough horizontal surface, and it can be written as mu k equals to Fk is equal to force of kinetic friction is equal to mu k into n, n is equal to m. Normal reaction is equal to weight of the block. This is the friction force acting between two surfaces, two contact surfaces, that is when a block of mass small m moves with velocity u over a rough horizontal surface, then frictional force coming into play is Fk is equal to mu k into m. And this kinetic friction force is counterbalanced by the force needed to move the body towards right, and that force needed to move the block in the right direction is mass into acceleration, m into a. So force applied on the body, force needed to act the body, needed to move the body on the rough horizontal surface is F equal to m into a. Suppose it is equation number 2, and this force m into a counterbalances the counterbalances or overcome the opposing friction force, kinetic friction force, which acts in the opposite direction to the motion of the body block. So we can write m into a equals to mu k into that is the force of kinetic friction Fk, and Fk is equal to mu k into n, and n is equal to m. So it is Fk is equal to mu k into m. So mu k kinetic friction force is equal to mu k into m. M will cancel out in both sides. Therefore, acceleration of the block on the rough horizontal surface is A is equal to mu k into G. What if the friction is sufficient, that is rough horizontal surface is more rough, then friction is sufficient to stop the block after covering some distance. Therefore, in place of acceleration, there will be retardation of the block. So we can take minus sign to indicate retardation of the block. So if the block ultimately the block moving on the rough horizontal surface will be slowed down, and ultimately it will stop. That is, final velocity of the block is 0. Then there will be retardation of the block. So negative sign is taken. So retardation of a block, negative sign shows retardation of the block. Therefore, retardation of the block over a rough horizontal surface, formula is A is equal to minus mu into G. एक्सीलरेशन एंड रिटार्डेशन दोनों के लिए स्मॉल ए सिंबल यूज किया जाता है, लेकिन रिटार्डेशन के केस में नेगेटिव साइन होता है, जबकि एक्सीलरेशन के केस में पॉजिटिव साइन होता है. तो रिटार्डेशन ऑफ द ब्लॉक ओवर ए रफ होरिजेंटल सरफेस एंड द फॉर्मूला इज A is equal to minus mu k into G, where mu k is the coefficient of kinetic friction between two surfaces, two contact surfaces, that is surface of the block and the horizontal surface. दोनों surfaces contact surfaces ब्लॉक का surface and the horizontal surface के contact में kinetic friction फोर्स एक्ट करता है. तो उन दोनों contact surfaces के बीच coefficient of kinetic friction जो कि constant of proportionality है, और यह रेशियो है kinetic friction force and normal reaction. So and G is acceleration due to gravity. So mu k is the coefficient of kinetic friction. Now we have to obtain the formula for stopping distance. If the block moving on a rough horizontal surface with initial velocity u, ultimately will be slowed down, and ultimately it will stop. Ultimately it will stop due to friction of the rough horizontal surface. That is, final velocity of the block is 0. Then the distance covered by the block over a rough horizontal surface before coming to rest is a stopping distance. So we have, for the stopping distance, we have used the formula equation of one of the equation of accelerated motion, v square minus u square is equal to 2as. Therefore, a stopping distance of the block, that is distance covered by the block before coming to rest. ब्लॉक के रेस्ट में आने के पहले, ब्लॉक के होरिजेंटल सरफेस पर रुक जाने के पहले जितना डिस्टेंस वो ब्लॉक कवर कर पाएगा, दैट डिस्टेंस इज कॉल्ड स्टॉपिंग डिस्टेंस. एंड दिस फार्मूला इज वेरी इंपॉर्टेंट टू सॉल्व ए प्रॉब्लम बेस्ड ऑन दिस फार्मूला. तो स्टॉपिंग डिस्टेंस ऑफ द ब्लॉक इज s equals to v square minus u square upon 2s. Here final velocity of the block is 0. So v is equal to 0. Putting v is equal to 0, final velocity of the block, minus u square, u is the initial velocity of the block, upon 2as. A is the retardation of the block, which is we have already obtained in equation number 3. Retardation of the block moving over a rough horizontal surface is small a is equal to minus mu k. यह रिटार्डेशन का फॉर्मूला है. जब कोई ऑब्जेक्ट, कोई ब्लॉक मूव करता है रफ होरिजेंटल सरफेस, तो रिटार्डेशन का फॉर्मूला A इक्वल टू माइनस म्यू के. वेरी यूजफुल फॉर्मूला. एंड देयरफॉर पुटिंग रिटार्डेशन ऑफ द ब्लॉक, दैट इज A इक्वल टू माइनस म्यू के इन दिस फॉर्मूला स्टॉपिंग डिस्टेंस, A इज इक्वल टू v स्क्वायर माइनस u स्क्वायर अपॉन 2s using the equation of accelerated motion, one of the equations of accelerated motion. Here final velocity of the block is 0. क्योंकि ब्लॉक रुक जाता है रफ होरिजेंटल पर मोशन एस डिस्टेंस कवर करने के बाद, तो स्टॉपिंग डिस्टेंस एस है. तो ब्लॉक जब रुक जाएगा तो उसका फाइनल वेलोसिटी ऑफ द ब्लॉक इज 0. सो वी हैव टू पुट A is equal to retardation of the block, formula for retardation of a block over a or on a rough horizontal surface is A is equal to mu k into G. So putting A is equal to mu k into G in this equation, A is equal to u square minus u square is equal to 2s, or stopping distance is equal to u square is 0 minus u square, that is minus u square upon 2a. Retardation of the block is minus mu k into G, minus mu k into G multiplied by s, multiplied by 2a, only 2a. न्यूमरेटर में s नहीं होगा, कि स्टॉपिंग डिस्टेंस तो हमने s लिखा है ऊपर, सॉरी फॉर दैट मिस्टेक. s इज इक्वल टू v स्क्वायर, दैट इज 0 स्क्वायर माइनस u स्क्वायर अपॉन 2a. न्यूमरेटर में s नहीं होगा, s न्यूमरेटर में होगा. इसको कैलकुलेट कर So S is equal to minus u square upon 2 multiplied by minus mu k into a का वैल्यू सब्स्टिट्यूट कर दिया गया इक्वेशन 3 से टॉपिक डिस्ट्रीब्यूशन का जो S is equal to 0 square a square minus u square upon 2a टॉपिक डिस्ट्रीब्यूशन के लिए जो फॉर्मूला इक्वेशन ऑफ मोशन यूज किया गया और नाउ माइनस साइन इन द न्यूमरेटर and denominator will be cancelled out. So we have a stopping distance of the block, that is distance covered by the block before coming to the rest. और कब हॉरिजॉन्टल सरफेस पर रुकने के पहले वो ब्लॉक जितना डिस्टेंस कवर करेगा वो स्टॉपिंग डिस्टेंस है. S इक्वल टू फॉर्मूला आ गया S इक्वल टू u स्क्वायर अपॉन 2 mu k into इस फॉर्मूला के हेल्प से स्टॉपिंग डिस्टेंस मालूम किया जा सकता है. कब हॉरिजॉन्टल सरफेस पर कोई ब्लॉक अगर मोशन कर रहा है इनिशियल वेलोसिटी u अगर दिया रहे और कोफिशिएंट ऑफ काइनेटिक फ्रिक्शन mu दिया रहे तो हम कैलकुलेट कर सकते हैं कि वह ब्लॉक हॉरिजॉन्टल सरफेस पर रुकने के पहले कितना डिस्टेंस कवर करेगा. सपोज किया जाए एक प्रॉब्लम इस पर स्टॉपिंग डिस्टेंस के लिए फॉर्मूला फॉर स्टॉपिंग डिस्टेंस का हमने ऑब्टेन किया. स्टॉपिंग डिस्टेंस ओवर रफ हॉरिजॉन्टल सरफेस इज S इक्वल्स टू u स्क्वायर अपॉन 2 mu k into g small g is the acceleration due to gravity which is 9.8 meter per second square. Sometime it is taken as 10 meter per second square. So stopping distance S equal to u square upon 2 mu k into g. Now a problem based on this formula. S equals to suppose a block is moving with suppose a block of mass m is moving on a rough horizontal surface with initial velocity, initial speed 10 meter per second, and ultimately it comes to rest. The block comes to rest on the rough horizontal surface. So what will be the distance covered by the block before coming to rest? If coefficient of kinetic friction between two surfaces is that is surface of the block and the rough horizontal surface is 0.10. So mu k is equal to given in the problem 0.10, that is 0.1. You can write it as therefore distance covered by the stopping distance of the block will be on the rough horizontal surface will be u square, that is 10 meter per second square upon 2 multiplied by mu k is given 0.1 multiplied by g is given in this problem 10 meter per second square in place of 9 meter per second square. 9 meter per second square is approximately 10 meter per second square. In this problem it is given acceleration due to gravity at that place is 10 meter per second square. So it is g is 10 से 10 स्क्वायर कैंसिल हो गया 10 बचा ऊपर में, that is 10 multiplied by 0.1 in the denominator. We can write 0.1 is न्यूमरेटर में हम 0.1 के लिए 10 यहाँ रिप्लेस कर सकते हैं. सो 10 into 10 एक 10 का स्क्वायर से न्यूमरेटर का 10 कैंसिल हो गया 10 बचा और फिर 0.1 के लिए और न्यूमरेटर में 10 हमने तो लिया है तो 10 into 10 upon 2 10 into 10 upon 2 that is 2 से 10 कैंसिल हो गया 5 हो गया 10 into 5 that is 15 meter. So stopping distance of the block over the rough horizontal surface is 50 meter in this problem. ब्लॉक हॉरिजॉन्टल सरफेस पर रुकने के पहले 50 मीटर डिस्टेंस कवर करेगा. अगर वह इनिशियल स्पीड 10 मीटर पर सेकंड की स्पीड से रफ हॉरिजॉन्टल सरफेस पर मोशन कर रहा है एंड अल्टीमेटली अंत में ब्लॉक रुक जाता है, फाइनल वेलोसिटी 0 हो जाता है. तो रुकने के पहले वह डिस्टेंस कवर करेगा इस इक्वल टू 50 मीटर, दैट इज स्टॉपिंग डिस्टेंस ऑफ द ब्लॉक ओवर द रफ हॉरिजॉन्टल सरफेस. वैल्यू ऑफ जी टेकन इट इज गिवन इन द प्रॉब्लम 10 meter per second square and coefficient of kinetic friction between two surfaces is 0.10, that is 0.1. Now we will discuss the motion of a block over a rough inclined surface. Downward motion and upward motion both, and in both cases we will obtain the expression for acceleration. So in the next topic we have to discuss motion of a block over a rough inclined plane. First of all, we have to discuss motion of a block on downward motion of a block over a rough inclined plane, and we have to find the acceleration of the block, downward acceleration. Very useful formula for problems. Suppose block of mass m lies on a rough inclined plane, if the inclination of the rough inclined plane is increased and the inclination exceeds the angle of repose, then that block moves itself without any external force. सपोज किया जाए कि m kg मास का कोई ब्लॉक किसी रफ इंक्लाइन सरफेस AB पर सिचुएटेड है, रखा गया है, अभी ब्लॉक रेस्ट में है। अब ब्लॉक का अब इंक्लाइन प्लेन का इंक्लिनेशन को बढ़ाया जाए, झुकाव बढ़ाया जाए हॉरिजॉन्टल से, और अगर रफ इंक्लाइन प्लेन का इंक्लिनेशन एंगल ऑफ रिपोज से ज़्यादा हो जाता है, अधिक हो जाता है, तो उस बॉडी को स्लाइड कराने के लिए, रफ इंक्लाइन प्लेन पर डाउनवर्ड डायरेक्शन में स्लाइड कराने के लिए कोई एक्सटर्नल फोर्स की जरूरत नहीं। वह ब्लॉक इटसेल्फ अपने आप खुद रफ इंक्लाइन प्लेन पर स्लाइड करेगा डाउनवर्ड डायरेक्शन। तो उसका क्या एक्सेलरेशन होगा, और यदि इंक्लिनेशन इंक्लाइन प्लेन का एंगल ऑफ रिपोज से कम है, तो उस सिचुएशन में विदाउट एनी एक्सटर्नल फोर्स बॉडी कैन नॉट will move down, that block or body cannot will move downward without any external force. But first of all, we have to discuss downward acceleration of a block if no external force is applied, that is angle of inclination is greater than the angle of inclination of the inclined plane is larger than the angle of repose. So we have to discuss now downward motion. ये फर्स्ट केस है, इसका डाउनवर्ड मोशन ऑफ ए ब्लॉक, वी हैव टू ऑब्टेन द डाउनवर्ड एक्सेलरेशन ऑफ द ब्लॉक ओवर ए रफ इंक्लाइन। डाउनवर्ड मोशन ऑफ ए ब्लॉक ओवर ए रफ इंक्लाइन प्लेन। And the situation if angle of inclination, that is inclination of the rough inclined plane, if the inclination of the rough inclined plane will be greater than or larger than the angle of repose theta, greater than angle of repose, we have already discussed in the previous video of this chapter, greater than, if the angle of inclination of the block is slightly increased so that it becomes greater than the angle of repose, greater than will be greater than, if the inclination of the rough inclined plane is increased and it becomes greater than the angle of repose theta. Angle of repose is denoted by the symbol theta. Angle of repose theta. Then the body, that block and the block or body will itself slides down over the rough inclined plane. Rough inclined plane. Body itself होगा without any external force. Without any external force. In that case, now one of the component of the weight mg sin theta will act downward along the incline, while frictional force, kinetic friction force acting between the surface of the block and the inclined plane will act in upward direction, that is Fk, which is equal to mu k into n, that is, and n is balanced by the vertical component, that is one of the component of the weight of the block. Weight of the block is acting vertically downward, which is mg. Suppose a block C moves downward, slides downward over the rough inclined plane AB when the angle of inclination of the inclined plane becomes larger than the angle of repose. So this angle theta is larger than the angle of repose. Therefore, the body will moves downward, slides downward without any external force. So one component of weight, that is nt sin theta, that is horizontal component of weight, and it will act towards downward, and which supports the block C to move to slide downward over the rough inclined plane. वेट का एक कंपोनेंट nt sin थीटा जो डाउनवर्ड एक्ट करेगा और वह ब्लॉक सी को सपोर्ट करेगा इंक्लाइन प्लेन पर बीए के लॉन्ग नीचे की ओर स्लाइड करने में, जबकि अपोजिशन दैट इज काइनेटिक फ्रिक्शन फोर्स एफ के ब्लॉक सी का सरफेस, ब्लॉक सी जिसका मास हमने सपोज किया है एम के जी, उसका वेट वर्टिकली डाउनवर्ड काम करेगा, एंड सरफेस इंक्लाइन सरफेस का नॉर्मल रिएक्शन ब्लॉक पर एक्ट करेगा अपवर्ड डायरेक्शन में एम। लेकिन यह नॉर्मल रिएक्शन जो सरफेस का है वह सरफेस इंक्लाइन सरफेस एबी के परपेंडिकुलर है, ओरिएंटल सरफेस एस के परपेंडिकुलर नहीं, क्योंकि इंक्लाइन प्लेन का इंक्लिनेशन अभी सिचुएशन में थीटा है क्योंकि एंगल ऑफ रिपोर्ट से थोड़ा सा ज्यादा है, जैसे कि बॉडी विदाउट एक्सटर्नल फोर्स के मूव स्लाइड कर रहा है डाउनवर्ड डायरेक्शन में। तो नॉर्मल रिएक्शन इंक्लाइन प्लेन के परपेंडिकुलर है, ओरिएंटल के परपेंडिकुलर नहीं, और इसलिए नॉर्मल रिएक्शन एंड वेट ऑफ द ब्लॉक दोनों एक दूसरे के अपोजिट जरूर हैं। नॉर्मल रिएक्शन ऑफ द इंक्लाइन प्लेन एक्टिंग वर्टिकली अपवर्ड टू द इंक्लाइन प्लेन ए बी, सपोज इन ओडी डायरेक्शन नॉर्मल रिएक्शन एन is acting vertically upward to the rough inclined plane, and it will balance the vertical component, that is another component of weight, that is mg cos theta, which is perpendicular to the inclined plane opposite to that of the normal reaction. Now n and mg cos theta, we can see that n and mg cos theta both are acting in the opposite direction, so they will cancel each other, they will balance each other, so there will be a case of vertical equilibrium in this case. So n is equal to mg cos theta, but mg sin theta is greater than the frictional force acting on the block in the upward direction. तो mg sin theta जो कंपोनेंट है वेट का वह फ्रिक्शनल फोर्स से क्या होगा, ब्लॉक का जो फ्रिक्शनल फोर्स ब्लॉक है क्या सरफेस एंड रफ इंक्लाइन प्लेन का सरफेस के बीच में जो फ्रिक्शनल फोर्स है उससे लार्ज होगा mg sin theta, therefore रिजल्टेंट फोर्स डाउनवर्ड एक्ट करेगा। तो रिजल्टेंट फोर्स नाउ एक्टिंग ऑन द ब्लॉक इन द डाउनवर्ड डायरेक्शन, therefore डाउनवर्ड रिजल्टेंट फोर्स acting on the block is equal to mg sin theta, that is the horizontal component of weight acting on the block in the downward direction along the inclined plane. mg sin theta inclined plane के along b से के along नीचे की ओर एक्ट कर रहा है, जो कि ब्लॉक को नीचे की ओर स्लाइड करा रहा है, और यह फोर्स फ्रिक्शन फोर्स जो कि ऊपर काम कर रहा है ब्लॉक सी एंड इंक्लाइन प्लेन के कॉन्टेक्ट सरफेसेस के बीच। तो इस फोर्स से लार्जर फोर्स होगा mg sin theta, तो रिजल्टेंट फोर्स भी डाउनवर्ड डायरेक्शन में होगा और एक्सीलरेशन भी ब्लॉक का इधर होगा डाउनवर्ड डायरेक्शन में होगा, जिसे इसे डिनोट कर सकता है, इस डायग्राम में रिप्रेजेंट किया जा सकता है ये डाउनवर्ड एक्सीलरेशन ब्लॉक का। तो रिजल्टेंट फोर्स mg sin theta माइनस fk इज फोर्स ऑफ काइनेटिक फ्रिक्शन एंड फोर्स ऑफ काइनेटिक फ्रिक्शन इज now fk is equal to mu k into n, and n balances the weight of the block, that is mg cos theta. So friction force is fk is equal to mu k into mg cos theta. So resultant force is now mg sin theta minus fk, kinetic friction force is equal to mu k into n, and n is mg cos theta, that is mu k mg cos theta. And we know that resultant force is equal to mass into acceleration from Newton's second law of motion. So in LHS we can write m into a, and therefore m will cancel out in RHS and LHS. So downward acceleration of the block without any external force, when inclination of the inclined plane is greater than the angle of repose, जब inclined plane AD का झुकाव बढ़ा करके एंगल ऑफ रिपोर्ट से ज़्यादा कर दिया जाता है, अधिक कर दिया जाए, तो बॉडी विदाउट एक्सटर्नल फोर्स के डाउनवर्ड डायरेक्शन में एक्सलेट होगा, स्लाइड करेगा, उसका एक्सलेशन का फॉर्मूला हो गया ए इक्वल टू जी साइन थीटा माइनस म्यू के कॉस म्यू के इंटू जी साइन थीटा, जी को कॉमन ले लिया जाए तो जी साइन थीटा, जी अंडर ब्रैकेट साइन थीटा माइनस म्यू के कॉस थीटा, क्योंकि जी सेकेंड टर्म में भी प्रेजेंट है, म्यू के एम जी कॉस थीटा टर्म था, एम जी साइन थीटा इसका पहला टर्म था, एंड एलएचएस में रिजल्टेंट फोर्स के बदले में ये जगह मास इनटू एक्सेलरेशन तो से कैंसिल हो गया था दोनों साइड में। therefore डाउनवर्ड एक्सेलरेशन ऑफ द ब्लॉक ओवर एन रफ इंक्लाइन प्लेन इज डाउनवर्ड एक्सेलरेशन ऑफ द ब्लॉक ऑन ए रफ इंक्लाइन प्लेन इज a इक्वल टू g sin थीटा, g एक्सेलरेशन ड्यू टू ग्रेविटी, g मल्टीप्लाइड बाय अंडर ब्रैकेट sin थीटा माइनस म्यू के cos थीटा, एंड सपोज इट इज इक्वेशन नंबर 1. But what if the angle of inclination of the inclined plane AB is smaller than that of the angle of repose, then some external force will needed to move the block downward, and let that external force is now another figure we can sketch, and in place of mg sin theta now two forces will act along the incline in the downward direction. One force is external force, say it is B, and another force is component of horizontal component of weight, one of the component of weight mg sin theta. If the inclination of the rough inclined plane AB is smaller than the angle of repose, then some external force say P is needed to move the block downward along the incline. So let that force is P. So two forces now acting downward along the incline. One force is P, external force, and another force is which was earlier in when no force was acting on the block, that is mg sin theta. And both forces P plus mg sin theta will be greater than Fk. Therefore, resultant force in this case is now is P plus mg sin theta is minus Fk, and Fk is mu k into n, mu k into n, that is n is equal to mg cos theta. So frictional force Fk is equal to mu k into mg cos theta. So in that case, downward acceleration of the block over a rough inclined plane with external force P. So another formula we will obtain. So in that case, downward acceleration with force A is given by P by M. Now we can obtain P upon M plus G under bracket sin theta minus mu k cos theta, and this is equation number 2. This is also downward acceleration, but with force external force A, with external force P acting on the block in that case. So this is also the formula for downward acceleration of the block with an external force P. That is A is equal to P by M, that is external force by mass plus M plus G, small g, under bracket sin theta minus mu k cos theta. This is another formula we have obtained in case of downward motion of a block over a rough inclined plane. One is downward acceleration of the block without external force, which is given by 1, that is A is equal to G, small g, under bracket sin theta minus mu k cos theta. And another formula for downward acceleration of the block with an external force P is A equal to P by M plus a small g sin theta under bracket sin theta minus mu k cos theta. Now we have to solve a pair of problems related to downward acceleration over a block without any force and with a force. And that problem is a block slides down over a rough horizontal surface of inclination 30 degree with the horizontal, and it slides down over the rough inclined plane from rest, and it covers 8 meter distance in first 2 seconds. Calculate the coefficient of kinetic friction between the surfaces. This is the problem. So in this problem, one, based on downward acceleration of the block, the block slides down over a rough inclined plane with rest, that is initial velocity is equal to 0, and distance covered by the block S is 8 meter. in first 2 seconds. That is, time is also given 2 seconds. And inclination of the rough inclined plane with the horizontal is 30 degree. That is 30 degree is the inclination of the inclined plane with the horizontal. And block starts from rest, that is initial velocity is equal to 0. And it covers, it slides down 8 meter in first 2 seconds. S is equal to 8 meter. सपोज किया जाए ब्लॉक रेस्ट में इंक्लाइन प्लेन के टॉप के पास था, इंक्लाइन प्लेन ए भी है, इसका इंक्लिनेशन दिया है प्रॉब्लम में 30 डिग्री और जेंटर Vx है, और 2 सेकंड में 8 मीटर डिस्टेंस कवर कर दिया, ब्लॉक स्लाइड कर दिया नीचे डाउनवर्ड। तो कोफिशिएंट ऑफ ब्लॉक का सरफेस एंड इंक्लाइन प्लेन के बीच का कोफिशिएंट ऑफ काइनेटिक फ्रिक्शन मालूम करना है। वी हैव टू ऑब्टेन uk इक्वल टू व्हाट, वी नो द ब्लॉक इज suppose block of mass m is slides down itself without any external force. So component of weight, one component of the weight mg sin theta will act downward, that is mg sin theta will act downward, mg sin 30, and normal reaction of the surface, inclined surface n is balanced by the balances the another component of weight, and another component of weight is mg cos theta, that is mg cos 30, and friction force is acting upward, that is Fk is acting upward, which is uk into n, that is uk mg cos 30. Now downward, for downward acceleration of the block on the rough inclined plane, we have the formula we have just obtained in equation number 1, that is a equal to g under bracket sin theta minus uk cos theta, that is mu g sin 30, in this case theta is 30, uk cos 30. This is downward axis. And using the equation of motion, we have s is equal to ut plus half at square. U is 0 and time is 2 seconds. ब्लॉक इंक्लाइन प्लेन पर 2 सेकेंड में 8 मीटर डिस्टेंस डाउनवर्ड स्लाइड करता है। तो s is 8 equals to u is 0, t is 2 seconds plus 1/2. Formula for downward acceleration is there, g into, in place of g, a downward acceleration we can write a small g sin 30 degree minus uk cos 30 degree. And we have now 8 equals to, take g equal to 10 in this case. So in place of g we can write 10, and 10 will cancel out, by 10 will cancel out from 2 by it is now 5. 10 is cancelled out by 2 and it is now 5. Sin 30 is half. We have taken g equal to 10 meter per second square given in the problem. So first term is 0, limit to the initial velocity of the block is 0, time into c equal to 2 second, distance moved by the distance covered by the block in the downward direction over the incline is 8 meter. 8 meter distance cover किया है block slide करके downward direction 2 second में. Weight equal to, now it is 5 under bracket sin 30 half 1/2 minus uk cos 30 is root 3/2, and it is now we have to calculate uk. अब हम लोगों को कोफिशिएंट ऑफ काइनेटिक फ्रिक्शन uk कैलकुलेट करना है. तो फर्दर वी हैव और 8/5 equals to, we can write 1 minus uk root under 3/2, 2 LCM हो गया RHS में, and it is now, or we can write now 8/5 into 2 by cross multiplication. 8/5 into 2, that is 16/5, that is 15/5 equals to 1 minus uk root 3. Therefore minus uk root 3 को LHS में लाया जाए, taking minus uk root 3 in LHS, we have to find coefficient of kinetic friction uk. So uk root 3 equals to 1 minus 16/5. One minus 16/5. uk root 3 is equal to 1 minus 16/5, and it is now we have, it is 5 minus 16, 5 minus 16/5. and mu k root 3, 16 upon 5 is equal to, we have 8 is equal to 5 under bracket 1 by 2 minus mu k, and the cos 30 is equal to root 3 by 2. So it is LCM is 2, it is 1 minus mu k root 3 upon 2 is 8 upon 5. 8 is the distance, S is the distance covered by the block in first 2 seconds. So we have 8 upon 5 is equal to 1 minus mu k root 3 upon 2, or by cross multiplication it is 8 into 2 is equal to 16 upon 5. 16 upon 5 is equal to 1 minus mu k root 3. Therefore mu k root 3 minus mu k root 3 है LHS में लाया जाए तो हो जाएगा mu k root 3 and 16 by 5 को LHS में ले गए तो it is 1 minus 16 upon 5. So it is mu k root 3 is equal to 1 minus 16 upon 5, and it is now 5 minus 16. It is 5 minus 16 upon 5. Now we have to calculate mu k. Therefore mu k is equal to 1 minus 5, that is 5 minus 16 upon 5 multiplied by in the denominator it is root 3. One term is missing, that is t square in the second term of this, that is 1 by 2 into 10 is expression due to gravity small g is equal to 10, because we have replaced a by downward acceleration of the block over the rocket line incline plane. We replaced a by g under bracket sin 30 minus mu k cos 30, and it is also in this formula distance covered by the body in first 2 seconds. or t second is 50 plus half a t square. Initial speed of the block is 0, so it is 0 into t is replaced by 2. And in the second term it is 1 by 2 into a is t under bracket sin 30 minus mu k cos 30. T is 10 meter per second square given in the problem, so it is cancelled out by 2 in the denominator, and now it is I under bracket sin theta minus mu k cos 30, and a term is missing here which is t square, and value of time is 2 seconds. So it is now we will write we will multiply this term by t square, that is 2 square, and 2 square is 4. Therefore now in the next step we have to multiply 4, and now this term becomes 8 upon 5, that is 5 into 4, now 20. So in the numerator now it is 20. 5 into 4 is 20 in the RHS. That term 4 was missing, that is t square, that is time is 2 second square, the second term. So it is now 8 upon 5 into 4, 20, and 8 by 20 is इसे कैंसिल किया जा सकता है 4 से. इट इज 2 upon 5, 2 upon 5, 8 by 20, 2 by 5 equals to 1 minus 1 by under bracket 1 by sin 30 1 by 2 minus mu k cos 30 into 3 by 2. LCM is 2, so it is 1 minus mu k root 3 by 2 is now 2 by 5. In place of 16 by 5, we have to write 2 by 5, or equals to 1 minus mu k root 3 by 2. Or we can write it as by cross multiplication, it is 2 into 2, that is 4 by 5 equals to 1 minus mu k by mu k root 3. In place of 16, we have to write 4 by 5. So it is now 4 by 5 is equal to 1 minus mu k root 3. Therefore mu k root 3 equals to 1 minus 4 upon 5, that is 5 minus 4 upon 5, that is 1 by 5. Therefore mu k root 3 is now 1 by 5. Now it is correct. Now we have I have missed the term t square, that is t equal to 2 second square in that expression. So it is now in 16 by 16 upon 5 we have to write 4 upon 5, and 1 minus 4 upon 5, 4 by 5 को RHS में ले जाया गया mu k root 3 को LHS में. So mu k root 3 is equal to 1 minus 4 by 5, that is LCM is 5 minus 4 upon 5, that is 1 by 5. Therefore coefficient of kinetic friction between two surfaces is now mu k. We can obtain mu k equals to 1 by 5 upon root 3, that is 1 by 5, and root 3 is 1.732, Now it is 1000 in the numerator, 1.7732 रूट थ्री का वैल्यू है, 1000 से मल्टीप्लाई करना होगा तो नीचे न्यूमरेटर 1732, तो 1000 अपॉन 5 मल्टीप्लाइड बाई 1732 एंड 1005 से कैंसिल हो जाएगा, तो दैट इज 200, दैट इज वी हैव 200 अपॉन 1732 coefficient of kinetic friction. After dividing 200 by 1732 से डिवाइड किया जाएगा 200 में, we will obtain 0.11. This is the coefficient of kinetic friction between two surfaces. Mu k is equal to 0.11 coefficient of kinetic friction between two surfaces. Now we have to take another problem which is related to this problem. If 4 Newton force is applied on the body of mass 4 kg, which slides down over the rough inclined plane from the rest. If in the previous problem the mass of body was not given, now mass of the block is 4 kg. It is 4 kg. M is equal to 4 kg. So in place of NT cos theta we have 4g cos theta, vertical component of the weight, and it will balanced by the normal reaction of the surface N. And applied force, external force on the body is also 4 Newton. So P is equal to 4 Newton, external force is 4 Newton, and one component of the weight mg sin theta, that is 4g sin theta now. M is 4g sin theta will act vertically, act tangentially over the rough inclined plane in the downward direction as usual. Mg sin theta x downward along the incline, right, which is one of the component, that is horizontal component of weight of the block, and weight of the block is now in place of mg we can write force. So and frictional force will act vertically upward direction, F k is equal to mu k into n, and it is now mu k into 4g cos 30, because n is balanced, n balances the vertical component of the weight 4g cos theta. In place of theta it is 30 degree, inclination of the plane is 30 degree, and this problem is related to the problem number 1. But external force 4 Newton and also mass of the block is given 4 kg in this case. In this problem we have to calculate distance covered by the block over the rough inclined plane in first 2 seconds. So we have to, first problem में 2 सेकेंड में ब्लॉक 8 मीटर डिस्टेंस कवर कर रहा था, नीचे डाउनवर्ड स्लाइड कर रहा था. अब जब एक्सटर्नल फोर्स उस पर ब्लॉक पर एक्ट करेगा 4 न्यूटन का, तो एक्सटर्नल फोर्स जब एक्ट करेगा ब्लॉक का मास भी 4 kg है, तब वह ब्लॉक इंक्लाइन प्लेन पर इंक्लिनेशन उतना ही है, 30 डिग्री है होरिजेंटल से. तो अब ब्लॉक होरिजेंटल सरफेस पर फर्स्ट 2 सेकंड में कितना डिस्टेंस कवर करेगा, तो एस इक्वल टू ut प्लस हाफ एटी स्क्वायर. ब्लॉक को रेस्ट से स्टार्ट करता है स्लाइड करना इंक्लाइन प्लेन पर डाउनवर्ड डायरेक्शन में, u तो 0 है, तो फिर लेकिन अब डाउनवर्ड एक्सेलरेशन हम इसमें मालूम कर देंगे. यहाँ पर दिया है प्रॉब्लम 2 डाउनवर्ड एक्सेलरेशन का केस है, लेकिन एक्सटर्नल फोर्स यहाँ पर बॉडी पर अप्लाई है 4 न्यूटन का, P द एक्सटर्नल फोर्स, एंड मास ऑफ द ब्लॉक इज गिवन इन दिस केस व्हिच वाज नॉट गिवन इन द problem 1. So it is 4 kg mass also, and external force is 4 Newton. Inclination of the incline is 30. On mu k is same problem. Mu k we have calculated, mu k is 0.11. coefficient of kinetic friction हमने कैलकुलेट कर दिया. और डाउनवर्ड एक्सेलरेशन के लिए, डाउनवर्ड एक्सेलरेशन इसमें मालूम कर रहे हैं एक्सटर्नल फोर्स के हेल्प से. we have to calculate first downward acceleration of the block by the external force 4 Newton. So A is equal to, formula is we have obtained already, P upon M plus G sin theta minus mu k cos theta, and P is 4 Newton, mass is also 4 Newton, plus T is 10. We have taken in the previous problem it was given, A is equal to 10 meter per second square, and it is now sin 30 degree minus mu k is now 0.11. We have obtained in the previous problem, and this problem is related to the previous problem, and 0.11 into cos 30 degree, and 4 by 4, that is external force is force, mass is force, it will cancel out, it is 1. So we have A equal to downward acceleration, A equal to now 1 plus 10 sin 30 half 1 by 2 minus mu k is 0.11 multiplied by cos 30 is root 3 by 2. And LCM will 2. LCM of the bracketed two terms will 2. So 2 will 10 will cancel out by 2. It is 5. Now 1 plus 10. 1 plus 10 it is. And now 5 it is. 10 is cancelled out by 2. So it is 5 under bracket 1 minus mu k multiplied by mu k is 0.11. So we have already substituted it 0.11 multiplied by root 3 is 1.73. We can multiply 1.73 by 1.73 by 0.11 to get the result, that is downward acceleration of the block. Now multiply 1.73 and 0.11. 1.73, 0.11, that is we have 371, 371, it is 3, 7 plus 3, 10, 0, 7 plus 1, 8, plus 1, 9, 1903, that is 0.1903, 4 place पर small letter मिलाकर. So now downward acceleration of the block, now we will obtain. So it is downward acceleration A equal to first term is 1 plus, that is 4 by 4 1, and second term is 10 by 2, 2 LCM है, तो से कैंसिल करा दिया गया 10 को, तो 5 हो गया. 5 अंडर ब्रैकेट 1 माइनस 0.11 multiplied by 1.73 is 0.1903. We can write only 0.19, or 0.19 is also written as 0.2. So we can write 1 plus 5 under bracket 1 minus 0.19 is 0.2. Therefore we have 1 plus 5 multiplied by 1.02 is 0.8. So downward acceleration in this case is 5 multiplied by 0.8 is 4.0, that is 4. 1 plus, that is 1 plus 4, we have obtained 1 plus 4, that is 1 plus 4.0, 0.8 into 5 is 4.0. So it is 1 plus 4, that is 5. So downward acceleration is 5 meter per second square. So distance covered by the body over the rough inclined plane, downward distance covered by the body over the rough inclined plane from rest in first 2 seconds is now S equals to, we have to obtain that distance, downward distance covered by the block in first 2 seconds. First 2 seconds में ब्लॉक के द्वारा कितना रफ इंक्लाइन प्लेन पर डाउनवर्ड डिस्टेंस कवर किया जाएगा. S इक्वल टू हो गया ut, u is 0 and t, that is half at square. We can write u is 0, so we can write only half at square, distance covered by the block in time to first 2 seconds, t equal to 2. And now we have obtained 1 by 2 multiplied by acceleration, downward acceleration we have obtained is 5 and time is 2 seconds, that is 2 square. 2 square से 2 square डिनोमिनेटर में 2 से कैंसिल होकर के 2 बचा, that is 5 into 2, that is 10 meter. So the block will cover, will slide downward, covering 10 meter distance in first 2 seconds, starting from rest. So distance covered by the block is 10 meters. Now in last we have to discuss upward motion of the block over a rough inclined plane, and we have to also obtain the minimum force needed to move the block up over a rough inclined plane, and also the upward acceleration of the block. So write the topic upward motion of a block over a rough inclined plane. Upward motion of a block over a rough inclined plane. Suppose a block of mass m is pushed upward over the incline, along the incline with an external force P. One component of the weight of the block mg sin theta will act downward tangentially along the inclined plane, and frictional force will also in this case will act downward along the incline because the body is moving up with the help of an external force P. So we have now, suppose an inclined plane AB making angle theta with the horizontal dx, and the block of mass m suppose is moving upward by an external force P. Weight of the block will act vertically downward. ब्लॉक का वेट मास एम हमने सपोज किया है तो डाउनवर्ड ब्लॉक का वेट काम करेगा, एंड नॉर्मल रिएक्शन सरफेस का ब्लॉक पर अपवर्ड डायरेक्शन में एक्ट करेगा. दिस इज नॉर्मल रिएक्शन ऑफ द सरफेस, एंड दिस विल बैलेंस द one component of the weight, that is vertical component of the weight, mg cos theta. नॉर्मल रिएक्शन के द्वारा इंक्लाइन प्लेन का नॉर्मल रिएक्शन, इंक्लाइन प्लेन ए बी इसका इंक्लिनेशन हॉरिजॉन्टल से हमने सपोज किया है थीटा. इस पर कोई ब्लॉक ए मास का ब्लॉक एक्सटर्नल फोर्स पी के हेल्प से अपवर्ड डायरेक्शन में पुल किया जा रहा है, खींचा जा रहा है, तो बॉडी का वेट वर्टिकली डाउनवर्ड काम करेगा, नॉर्मल रिएक्शन सरफेस का अपवर्ड काम करेगा. नॉर्मल रिएक्शन और वेट एक दूसरे को के जस्ट अपोजिट नहीं है, एक दूसरे को बैलेंस नहीं कर पाएंगे, इसलिए ब्लॉक का वेट mg का एक कंपोनेंट वर्टिकल कंपोनेंट जो कि इंक्लाइन प्लेन के परपेंडिकुलर है लेकिन नॉर्मल रिएक्शन के अपोजिट डायरेक्शन में है, mg cos थीटा, और यह कंपोनेंट वेट नॉर्मल रिएक्शन के द्वारा इंक्लाइन सरफेस का ab का नॉर्मल रिएक्शन n के द्वारा बैलेंस हो जाएगा. जबकि डाउनवर्ड कंपोनेंट जो इसका हॉरिजॉन्टल कंपोनेंट है जो इंक्लाइन प्लेन पर इंक्लाइन प्लेन के लॉन्ग डाउनवर्ड एक्ट करता है mg sin थीटा, वह डाउनवर्ड इंक्लाइन प्लेन के लॉन्ग डाउनवर्ड एक्ट करेगा mg sin 30, प्लस फ्रिक्शनल फोर्स भी ब्लॉक का सरफेस एंड हॉरिजॉन्टल प्लेन के बीच में काइनेटिक फ्रिक्शन फोर्स F के भी एक्ट करेगा डाउनवर्ड डायरेक्शन में. बट द बॉडी इज पुल्ड अप by the external force P. So external force P will be greater than mg sin theta plus F, which both together act along downward over the inclined plane, and there will be upward acceleration of the block, which will be, suppose it is a small a. So resultant force acting on the body in this case is resultant force acting on the block of mass m, which is pulled up along the incline plane पर ऊपर जो खींचा जा रहा है एक्सटर्नल फोर्स P के द्वारा. तो रिजल्टेंट फोर्स एक्टिंग ऑन द ब्लॉक ऑफ मास स्मॉल m pulled up along the incline means inclined plane, rough inclined plane, along the incline or rough inclined plane is resultant force is equal to external force P minus P अपवर्ड फोर्स है और उसमें से माइनस हो जाएगा mg sin थीटा, वेट का एक कंपोनेंट डाउनवर्ड डायरेक्शन में इंक्लाइन प्लेन के लॉन्ग एक्ट करता है, प्लस फ्रिक्शनल फोर्स F के. तो mg sin थीटा प्लस फ्रिक्शनल फोर्स काइनेटिक फ्रिक्शन फोर्स F के इज एक्टिंग डाउनवर्ड, एंड इट इज नाउ resultant force is mass into acceleration, that is m into a बराबर P minus mg sin theta plus Fk is equal to mu k mg cos theta. Mu k into n, kinetic friction force acting downward because the body pulling upward by an external force P. तो kinetic friction force नीचे काम करेगा F के डाउनवर्ड डायरेक्शन में इंक्लाइन प्लेन के along mg sin theta के साथ. mg sin theta is also acting along downward direction along the incline. mg sin थीटा और F के दोनों डाउनवर्ड डायरेक्शन में इंक्लाइन प्लेन के लॉन्ग वर्क करेगा, एक्ट करेगा, जबकि एक्सटर्नल फोर्स भी ऊपर की ओर, लेकिन एक्सटर्नल फोर्स क्योंकि अपवर्ड मोशन हो रहा है ब्लॉक का इंक्लाइन के ऊपर, तो इसलिए एक्सटर्नल फोर्स की का वैल्यू ज़्यादा होगा, mg sin थीटा प्लस F के से अधिक होगा. देयरफॉर रिजल्टेंट फोर्स भी P में से एक्सटर्नल फोर्स में से ये दोनों फोर्स जो डाउनवर्ड डायरेक्शन के लॉन्ग एक्ट कर रहे हैं ब्लॉक पर, ब्लॉक सी पर, क्योंकि आप इंक्लाइन प्लेन पर इसका मास हमने सपोज किया है. तो एक्सटर्नल फोर्स P में से mg sin थीटा प्लस काइनेटिक फ्रिक्शन फोर्स माइनस हो जाएगा, इस mg sin थीटा प्लस F को ब्रैकेट में रखा है. एंड एफ के इक्वल टू म्यू के इंटू एन होता है और नॉर्मल रिएक्शन बैलेंस करता है एम जी कॉस 30 को एन इक्वल टू एम जी कॉस 30 सो इट इज एम जी कॉस थीटा हियर tangent is theta is not given in the previous problem it was given 30 degree angle of inclination of the rough or downward here the angle of inclination of the rough inclined plane AB with horizontal we have taken theta so it is m into a resultant force from Newton's second law of motion is m into a in LHS is equal to p minus mg sin theta p minus under bracket mg sin theta plus mu k into n is mg cos theta mu k into n and n is equal to mg cos theta so it is now a equal to so downward acceleration is now a dividing both sides by m mass of the block it is m and m will cancel out in the second both terms inside the bracket so we will obtain a is equal to p by m minus g is also common g sin theta plus uk cos theta and this is uk is the coefficient of kinetic friction between the surface of the block C and inclined plane between two surfaces that is surface of the block C and the surface of the inclined plane contact surfaces kinetic friction और ये upward acceleration के लिए फॉर्मूला है this is the acceleration upward acceleration of the block suppose this is equation number 1 in this topic upward motion or upward motion of a block over a rough inclined plane this is the expression for upward acceleration now if the block is just moved up then acceleration is 0 or body is moving upward with the uniform acceleration in that case acceleration will equal to 0 so upward acceleration of the block is a equal to p by m p is the external force acting on the block in the upward direction p external force है जो block पर upward direction में करता है a बराबर p by m minus p sin theta plus mu k cos theta is the angle of angle between the inclined plane which makes with the horizontal थीटा वह एंगल है जो विदाउट इंक्लाइन प्लेन नेगेटिव होरिजेंटल bx के साथ वर्क करता है तो अपवर्ड एक्सेलरेशन ऑफ द ब्लॉक a इक्वल टू p by m minus g small g with the acceleration due to gravity under bracket sin theta plus mu k cos theta now if we have to find the force the external force acting on the body to just pull it up अगर बॉडी को जस्ट ठीक ऊपर की ओर पुल किया जाए तो उस समय एक्सेलरेशन 0 होगा या ब्लॉक यूनिफॉर्म वेलोसिटी से अपवर्ड डायरेक्शन में मोशन कर रहा है तो भी एक्सेलरेशन 0 होगा पुटिंग एक्सेलरेशन इक्वल टू 0 इन दैट केस तो फॉर द ब्लॉक टू जस्ट मूव अप over the on the rough inclined plane putting acceleration a of the block in LHS equation upward acceleration in place of upward acceleration in equation 1 putting a equal to 0 we have a equal to 0 equal to p by m minus g sin theta plus mu k cos theta and we will obtain now p equal to p the upward force to move just the block upward or block is moving upward with constant velocity, uniform velocity, then acceleration is 0. So p is equal to now we will obtain p is equal to mg 0 acceleration 0 हो गया है तो 0 बराबर is equal to p by m minus g sin theta under bracket sin theta plus mu k cos theta therefore p by m is equal to g sin theta plus mu k cos theta p by m is equal to इसको LHS में लाया जाए नेगेटिव टर्म को LHS में 0 है RHS में आने पर यह टर्म पॉजिटिव हो जाएगा p by m is equal to p sin theta plus mu k cos theta therefore p is equal to mg under bracket sin theta plus mu k cos theta this is the formula for the minimum force required to pull the body up over the incline then acceleration is 0 force is minimum then acceleration is minimum acceleration of the block in that case will be 0 and this is the formula mg p is equal to mg sin theta plus mu k cos theta or we can also write it as mg sin theta plus fk in terms of friction force fk we can write it upward force p is equal to downward force mg sin theta plus fk to move the body that is minimum force needed to pull the body upward is equal to p is equal to mg under bracket sin theta plus mu k cos theta otherwise or mg sin theta plus fk p is equal to p upward force downward force is component of one component of weight mg sin theta plus friction force Fk. And in place of Fk we can write mu k into n, mu k into mg cos theta. So this is the required formula. So this is formula number 2. Now in last we have to solve a problem based on this formula, that is upward motion of the block over a rough inclined plane. Suppose the problem is a block. Suppose a block of mass 20 kg is moved up with the help of an external force, say P. The inclination of the rough inclined plane is horizontally 30 degree. So what will be the minimum force required to pull the block upward over the rough incline? तो minimum force के लिए फॉर्मूला हमने ऑब्टेन किया, P इक्वल टू mg अंदर ब्रैकेट sin थीटा प्लस mu k cos थीटा, and we have coefficient of kinetic friction between the block and the surface is 0.5. So in this problem we have to calculate minimum force to move the block upward, or minimum force to move the block just up over the rough inclined plane. So we have in this case P is equal to nt sin theta plus Fk. So in this problem mass of the block is given m is equal to 20 kg, and inclination of the rough inclined plane with horizontal 30 degree. Mu k is given 0.5. We have to calculate minimum force needed to pull the body up. So P is equal to what? Using the formula for minimum force, which is due to body to pull upward over the incline, or the force required to pull the block just upward over the rough inclined plane without acceleration. Acceleration is 0 in that case. So using the formula we have P is equal to mg sin theta plus Fk. Fk is the force of kinetic friction which is acting vertically downward, and Fk is mu k into n, and n balances the normal reaction. N is the normal reaction which balances the vertical component of the weight mg cos theta. So it is n is equal to mg cos theta. So P is equal to mg sin theta plus Fk, and Fk is now Fk is equal to mu k into n, and n is equal to mg. N is equal to mg cos theta. Mg cos theta, and we can take mg common. So it is mg under bracket sin theta plus mu k cos theta. M is 20 kg, G is 9.8 in this case, in this problem. Sin 30, theta is inclination of the rough inclined plane with the horizontal is 30 degree. So it is sin 30, and mu k is given 0.5, coefficient of kinetic friction, and cos 30, it is cos 30, theta is 30 degree. So we have now we will get the result after calculation. So we have now it is 0 will cancel out by 9.8, that is decimal. 9.8 is 98 by 10, so 0 will cancel out. 0 is implied by this decimal. So it is 98 into 2, it is 196. Under bracket sin 30 half plus 0.5 cos 30 root 3 by 2. And it is now it is LCM is 2, so 196 by 2. 1 plus under bracket 1 plus 0.5 multiplied by root 3 is 1.73. 1.73 में 0.5 से मल्टीप्लाई किया गया, मल्टीप्लाई 1.73 multiplied by 0.5. We have 5 into 3 15 into 1 7 into 5 35 36 3 5 into 1 5 plus 3 8. We have 0.865 after multiplying 1.73 by 0.5, it is 0.865, and 196 by 2, it is 98. So LCM is 2, so it is 196 by 2. So it is now 98 under bracket 1 plus 0.5 multiplied by 1.73, 0.865. That is, we have now 98 multiplied by 1 plus 0.865 is 1.865. Now we can multiply 98 and 1.865 is nearly 2. 1.865 is nearly 2. So it will nearly 98 into 2, that is 96 Newton. But after multiplying 98 and 1.865, we will obtain nearly 183 Newton. And if the value 1.865 is taken as 2, then it will in that case 98 into 2, that is 196 Newton. But 98 into 1.865, after multiplying it, we will get nearly 183 Newton. So the minimum force required to move the body up over the rough inclined plane is nearly 183 Newton. Answer. This is the minimum force to move the block over the rough inclined plane without acceleration. H 1 P equal to external force equal to 183 Newton. Now this video is completed. Thanks all of you for watching my videos or watching my YouTube channel, Physics Quantum Classes.